practice 7-2 scientific notation. So whenever we have really big or really small numbers, we use something called scientific notation. So let's say you are talking about something really, really, really big, like the number of atoms in the human body. So you have something with like a gazillion zeros. Instead of writing out a really long number, you can just say 3 times 10 to, I don't know, like the 28th power, and what you know is that the number starts with a 3 and it is 28 digits long. So after this 3 you have like 28 zeros. You can also go the other way. If you have 3 times 10 to the negative 28th power, then you know you have a number that's really, really, really tiny. So you have 0.000028 of these 3. So scientific notation is really helpful when we're talking about really, really big numbers or really, really small numbers. So we're going to do a few problems, and let's start with number 1. So we have 3 times 10 to the 4th. So the way you change this to standard notation, what standard notation means is just a regular number, like a decimal that is not in scientific notation. So what you do is you start with your first number, okay, 3, and anytime you just have a number, you don't see a decimal, it is at the end. And what you're going to do is you're going to move this decimal 4 times. So there's no numbers after this, so we're going to just go 1, 2, 3, 4, and we're going to fill in these blanks with zeros. So our final answer is going to be 30,000, and that is number 1. So number 4, we're doing every third problem. We have 2.34 times 10 to the negative 5th. So every time you see a negative exponent, what that means is we're making the number smaller. So we have 2.34, and instead of going to the right, we're going to the left because this is what makes the number smaller. So we're going to start at your decimal and we're going to go left 5 times. 1, 2, 3, 4, 5. And we are going to fill these in with zeros. And your decimal goes right here. So we have 0.0000000234. And this is your answer for number 4. So for number 7, we have 42.4 times 10 to the 6th power. So what we are going to do is we are going to move the decimal to the right. We're going to start here, and we're going to go to the left the right 6 times. So you're going to go 1, 2, 3, 4, 5, 6, and the spaces where we don't already have numbers, we are going to fill in zeros. So our answer is 4240000, and commas after every third number, so that's 42,400,000, and this is our final answer for number 7. Okay, so for number 10, it says write each number in scientific notation. So right now it is in standard notation, so we have 24 million over here, and the decimal is over here. So what we're going to do is, if we want it to be in scientific notation, we want the first number to be in between 1 and 10. So we are going to move it 1, 2, 3, 4, 5, 6, 7. We want the decimal to be right here because 2.4 is in between 1 and 10. So we have 2.4 times 10, and we're going to count how many times we move to this. So 1, 2, 3, 4, 5, 6, 7. So we are going to put 7 over here. We have 2.4 times 10 to the 7th power. Okay, 13. We have 385 times 10 to the 3rd. So this is not in standard notation, but it's also not in scientific notation because this number is too big. We want this number to be in between 1 and 10. So we don't see a decimal, so we know that the decimal is at the end over here after the 5. And we want to move it 2 times. So now we have 3.85, which is a number between 1 and 10, times 10, and because we moved it twice, we want to add 2 to this exponent. So 3 plus 2 is 5. So this is our final answer for number 13. Number 16. Okay, we have 4 times 10 to the 5th. So what you're going to do here is you're going to take the number on the outside and the number on the inside and just multiply them together. So 4 times 4 is 16, and this stays the same, times 10 to the 5th power. But we're not done yet because 16 is bigger than 10, so we want to move the decimal once. So it's 1.6, and what that means is we are going to add 1 to the exponent. So we have 1.6 times 10 to the 6th power. And this is your answer for number 16. Okay, for number 19, we have 8 times 9 times 10 to the 6th power. So we're just going to multiply these first two numbers, and 8 times 9 is 72. So we have 72 times 10 to the 6th power because this stays the same. Okay, we know that the decimal point is after the 2 because we don't see one, and we're going to move it once back because we want this first number to be in between 1 and 10, so 7.2. And since we moved the decimal once, we want to add 1 to this top exponent. So we have 7.2 times 10, and 6.1 is 7, so 10 to the 7th power. And this is our final answer for number 19. And number 22, we have 3 times 1.2, 3 times 1.2 times 10 to the negative 4 power. So we're going to multiply these two numbers. So 3 times 1.2 is 3.6 times 10 to the negative 4th power because this stays the same. And if we look over here, 3.6 is already in between 1 and 10, so we can leave it the way it is. So that means that this is our final answer, 3.6 times 10 to the negative 4th power. And that is it for practice 7-2.